Hey guys, so today we're going to be talking about Venn diagrams, unions, and intersections. This is really going to be a tool to help with probabilities. You can utilize it or not utilize it. It's really up to you, but maybe you've seen Venn diagrams in the past in English just to organize your thoughts. Well, here we're going to look at using our tool of Venn diagrams to organize probabilities and looking at the probability of events. So really it's a visualization. So some people are very visual people, myself included. I like to visualize the probabilities and kind of helps me organize my thoughts just a little bit better, especially when it comes to looking at the whole sample space as a whole and kind of figuring out where those probabilities are putting into place. Now, when we're using this, I'm going to utilize the formulas that we were talking about in the past as well. But for right now, taking a look at Venn diagrams, it's just a way to represent the events. It displays the potential probabilities. When you're looking at a whole box, so with the two circles, it includes the whole box. The whole box represents the total sample space. Now remember when we talked about our sample space, we had the probability of our sample space is always going to be 1. So all of the probabilities inside those sample spaces should equal 1. So the circles themselves represent the probabilities of each event. So for example, in the middle, that's where I always really like to start when I'm making these, is where both our first event, so event A, and also our event B are going to be occurring at the same time. So this is that they're both occurring, so A and B. Over here, to the left of it, this is the probability that A occurs but not B. So everything in this circle here would represent, just like this little crescent, would represent A occurs but not B. Over on this side, this is where B occurs but not A, because there's no overlapping there. And then you also have a number that's going to be out here, where neither even A or B are going to be occurring at the same time. And then we have our full sample space. So you should have 4 different numbers when you're doing your Venn diagrams. You should always have 4. So let's go ahead and take a look at what unions and intersections, because we've talked about these in the past, and we talked about that or and our and now we're just kind of putting more symbols to those to and or representations of probabilities. So remember with our or probability, so our or probability is that the probability that either or occurs. So that either event, either or, so either event A or event B occurs. When we're looking at our probabilities here, we're taking a look at, let's see if I can adjust this and adjust the lighting a little bit. So we're looking at something called the union. So the union represents the or, so probability of A or B occurring. So we're looking at our symbol, which would be a U shape. Think U would be union, U is going to be or. When we're looking at our intersection here, the intersection is going to be representing the and, so the probability that event A and B occur, so that they both occur together. So this is going to be the probability that both occur together. Now, when we're looking at our intersection, think union has a U shape. Our intersection is going to have this N shape, this upside down U shape instead. So intersection would be the probability that both occur. So when we're looking at some of these shaded regions for our Venn diagrams, when we have our shaded region of everything in A plus everything in B plus that intersection, that overlapping, this is the probability that A or B are occurring. So either A is occurring or B is occurring. This is what our union is going to look like. So we're going to have our probability of A union B, or A or B occurring. So this is the probability A or B is going to be happening. Because everything in that shaded, we have everything in A plus everything in B. Now looking here, the shaded region's right in between. So it's that cross, it's the overlapping piece that we were talking about with the and probabilities. So this is going to be our probability of A and B happening, or the probability it's our intersection. So we have P, probability of A intersection B. It's probability of A and B occurring. So A and B happening at the same time and occurring together. Let's take a look at a few more. So notice here we have our entire box shaded except for A. So everything is shaded except for A. So this is our probability that even A is not occurring because everything is shaded but A. So this is the probability, it's our complement. We have our A complement. Remember we talked about complement and the basic probability where we have our whole sample space minus the probability of A happening. So this is the probability of A not happening. Looking at this shaded space, notice how A and B are not happening. So this is the fact that we have A and B not happening at all, and that's everything on the outside, the fact that neither are occurring. So I would have the probability of A not happening and, which is our intersection, B not happening. So B complement. This is just in words. We have our probability of A and B not happening together. So we're going to do a couple more of these shadings on the next page, and then we're also going to apply it to a problem and kind of figure out what that's going to take a look at. So looking at our next piece, we're going to shade the probabilities of the following notations. So we have our probability of A intersection, so and B not happening. So we have our probability of A. So everything in here in A is going to be our A happening. And though, so we want everything in A not happening, but we don't want B to occur. So we want to figure out where A occurs, but not B. So where does A occur? A occurs all in the circle, but not B. That's only in this little section right here. So we're going to figure out where does A happen, but not B? All over here. All right. So our next one is a union. So either or happening. So A not happening or B. So we want to figure out, okay, where does A not happen? So let's go ahead and shade. Where does A not happen? Well, A happens everything inside this circle, right? So I want it not to happen. So I'm going to shade everything outside of our A happening. Because everything inside here, A happens. So I have everything outside of A occurring here. So not A, so meaning everything outside of A, or, so including, so adding in our piece of where B occurs. Well, B also occurs right in here. So we'd have everything shaded but that region. Okay, so taking a look at the next one, we have the probability that A does not happen. So once again, where does A not happen? So outside this circle is where A does not happen. So we're looking at where A does not happen. That includes with our event B. So we have all that pieces here. And then we want or, so adding in, so this or, so plus, everything outside of set B. Well, everything outside of B is everything outside of this guy. So I want to include this piece. So I'm adding in my shaded pieces. So think about where does this happen plus this when we have our union. Here we're looking for this and this. So we're looking for the A and not B occurring. So everything in A and not B, it would just be the shaded region there. Here we're looking for added pieces put together. So we can also use these to fill in numbers and use as a tool to help us figure out some values and kind of put a visualization to a two-way table. And that's what we're going to do next. So we have in your statistics class, you're interested in exploring the taste preference of your classmates. You have two tastes, sweet and salty. You have 25 students were asked if they prefer both, only sweet, only salty, or neither. And you have your two-way table. And we're going to organize this into a Venn diagram. So where I always like to start is figuring out, okay, what does event A mean and what does event B mean? So event A is going to be that they prefer sweet. And event B is that they prefer salty. So we have everyone here is going to be preferring sweet. Everyone here is going to be preferring salty. Where I like to start with everything is in our middle, so in our intersection. So where did they prefer sweet and salty? So looking at sweet and salty in my diagram here, I have 6 individuals in my two-way table that were yes to sweet and yes to salty. So I'm going to put 6 right in that middle because that's my overlap. I have the 6 individuals that were in both. All right. Now I want how many people, so how many people said that they like sweets but not salty. So sweet but not salty would be my 11 here. So this is just the sweet guys out of the salty, and you can kind of see this would be the total amount of people that said they prefer sweet. Well, 11 plus 6, we can check our answer. We get 17. All right. So now in this little piece, so for this guy, I want the fact that they did not prefer sweet, but liked salty. So they want salty, but not sweet. So like salty, but no sweet. Yes, salty, no sweet. We have our 7 people there. And we can see also for those that said yes to salty, because our event B is salty, we have yes to salty. Well, that's 6 plus 7 should get me 13, which matches up. 6 plus 7 gives me a total of 13. All right, last but not least, though, we have that one person that said that they did not like either. So the fact that they did not prefer salty or sweet, it was neither salty or sweet. We have that one person in here that should go outside, but still are included in our 25 individuals. If I add up all my numbers, I'm going to get 25. Now, you could also use this with probabilities. So if you use this with probabilities, we would just take our values because we're only using our joint frequencies. So using our middle pieces to find and put into our Venn diagram. But here we're looking at, because we're looking at 2 different events that are occurring, looking at the joint. You can look at 6 divided by 25 and you can get your probabilities easily if you want to work with that, depending on how we would do. We would divide all of these by 25, and when we would add up all 4 of those probabilities, we should get 1. So you can use either or, so you can kind of utilize this as probabilities and fill those probabilities in, especially if it says the probability of selecting someone that prefers sweet and salty is this. You can put the probability in the middle as well. So you can use Venn diagrams in many different ways, but right now we're just going to look at our total numbers instead of looking at anything else. Once again, you can use our formulas that we've used in the past if you want to do that. You can just use the two-way table. This is just another tool to help you organize your probabilities. So looking at rating our intersections and unions here, we have the probability of A intersection B. So remember, the intersection means and, so we want the probability of A and B. So we want the probability of A, so the fact that they want a salty and sweet. We're going to look at our 6 people out of the total of 25. So out of our total of 25 individuals, we have 6 out of 25 which said they liked both or preferred both, and so we have that as 0.24. So interpreting the probability, we can have this is the probability a student, and we can say in class, because this is in a class, prefers both sweet and salty food is 0.24. All right. A union B means A or B. So we want the probability that a student likes sweet or salty. So we want either or. So when we're looking at either or, we're going to look for the values in A. So everything in A. So we got our 6 plus, or 11 plus 6. But we also have or B. So plus our 7. And we take all those, add those together, and we divide by 25 people. So we take 11 plus a 6, because that is in A, plus those that are in B. I would have 11 plus 6 plus 7, and I divide that by by 25, and I get 0.96 as my probability. So interpreting this, we say this is the probability. A student in class prefers either sweet or salty food is 0.96. So you can either pause this video and try the rest of these, but I'm going to go through all of them and explain. So if you want to go ahead and take a pause, you're more than welcome to, or if you just want to keep it playing and have it explain as we go, you can do that as well. So we're finding the probability of A and B not B. So we want the fact that we have people that are in A and not in B. So looking in A, we're going to have everyone that is going to be in A, but not in B. So we're going to be looking at the 11 out of the 25. So we're looking for those that are in A but not in B, so that do not like salty food. And we're going to have 11 out of that 25. So we have yes to sweet but no salty, and we have 11 out of 25. We divide that, and we have 0.44. Once again, you could utilize the table too and say, okay, I want yes, they have sweet but not salty, and salty would be that 11 out of our 25. So yes to sweet and not salty, so we'd have the 17 but not the salty, would be 11 out of 25. So this is the probability that a student in class prefers sweet food but not salty food. This say is 0.44. That's the probability. Okay, so now we have our probability of not A. So we're looking at outside of A. So outside of A in general is going to be our 7 and our 1, or B. So looking at, or the fact that they like salty. So we would look at 6, 7, and 1 as our added numbers. So we're going to take our, out of our 25, so we're looking outside of A, which is outside 7 and 1, but adding in also our B. So adding in B, which is 6. So we have 6 plus 7 plus 1, and we would get our 0.56. Now, you could also use your formula if you wanted to. So this is still an OR probability. So looking at our OR, we would look at how many people said no sweet. So if I wanted to use our formula here, we say no sweet, which was 8 out of the 25. We would add in those that said yes to salty, which is our 13 out of 25. And we would subtract out those 7 individuals that were overlapping. So you could do either one. It doesn't really matter. You're going to get the same answer of 0.56. So once again, utilize your Venn diagram, or just use your two-way table and know your formulas that we talked about in the past. Totally up to you. All right, but this is the probability, because we have to interpret still. The probability a student in class prefers not sweet foods, so no sweet foods, so no sweet, or likes salty food. And that is 0.56. So taking a look at our next example, we have A or not B. So we're looking at those that like sweet. So looking at sweet, we're looking at all those that like sweet. So we're looking at looking at our 11 and 6, making sure that we have either we want in A or not B. So looking at or not B, well, or not B would be also adding the 1 in, because that one person is not in B. So looking at the 11 and 6, because they're in A, or we got to add in that one person that is not in B. So we would have our 11 plus 6 plus our additional 1 that is not in B out of the 25 individuals, and we get 0.72. Now, once again, you can use the formula. You could use the formula, either one. If I wanted to use my formula, I would want the probability of A. So out of everyone that said yes to sweet, which was our 17 out of 25, we're going to add in those are not in sweet, or sorry, not in salty. So not salty. Looking at no salty, that was our 12 out of 25. But we have to subtract out the overlap. So we had yes to sweet, no to salty. We had 11 people that we had an overlap in. So we want to make sure that we subtract out those 11 people that like sweet but not salty snacks. And you're going to get the same exact answer of 0.72. So either way, it doesn't matter how you look at it or what you want to do, you're going to get the same answer. So looking at the interpretation of this, you would want the probability of a student in class that prefers your sweet food but not salty food is 0.72. So make sure you have that written down. That's how we're going to know that you took notes. So once again, we have the probability that a student in class prefers sweet food but not salty. Okay. Looking at A complement and B complement. So we're looking at those that do not like sweet and do not like salty. So looking at those that are not in A, so not in A, and not here. So the 11, the 6, the 7, they're not in both of those. So I just have that one individual that is neither. So I'd have 1 out of 25, which is our 0.04. Once again, you could look at no sweet and no salty. No sweet and no salty, that's one individual out of the 25. Utilize your table or know what your AND probability is. This is the probability that the person or a student in class does not like sweet or salty foods. So that's what you should have written here. And that's all of which you're going to be doing for your Venn diagrams. You have some practice, so once again, you're going to have some type of probabilities here. Start in the middle and try to figure out then which ones are, you can fill in these 4 different numbers. Okay, same thing here. Start in the middle. You can use these as individuals and use them as numbers, and you can just put probabilities in here. You can convert those decimals, or sorry, those percents into decimals if you really wanted to. On the back, you have a Venn diagram, or sorry, a two-way table that you're going to need to fill out, and then it'll help you kind of go from there. Right? Other than that, have a great day, and I'll talk to you soon.